Hello students. So now in this lecture series, students, we are going to start SAT physics. Okay student, SAT physics. So what is this SAT physics? SAT physics is basically standardized test. It is basically a standardized test in America, okay, for getting admission into the American colleges for a particular exam subject, main exam subject, okay. And our subject is physics. Okay students, so our subject is physics. So now let's start, and we'll, for this, the reference book which we are using is this. Let me share the screen students. This is a reference book. Okay, cracking the SAT subject test, physics subject test, everything you in 15th edition, everything you need to know to help score a perfect 800. Okay, it contains 2 full-length practice tests with complete answer explanations, comprehensive review of key physics concepts, targeted strategies for acting the exam. Okay students, so let us start reviewing this book. Okay, let's go. Okay, stop. So from we will start students, we will start from kinematics students. Okay, because the basics, rest of the thing is mathematics, which is scientific notation. It contains basic trigonometry review, vectors, summary. So we will not do this. Okay, basically we'll start from kinematics, which is from where the physics basically starts. Okay, so let us start with kinematics. Okay, as you can read the theory here, you can go through the theory, but our main target here in this lecture series is I will just solve the numerical problems. Okay students, okay, and the theory which is, or the concepts which are contained in the numerical problems, we will solve it here. Okay, so let us go down, go more. Okay students, here is a question here. A rock is thrown straight upward from the edge of a cliff, of 30-meter cliff, rising 10 meter, then falling all the way down to the base of the cliff. Find the rock's displacement. Okay, so students, let me copy this question for you on the whiteboard. Okay students, let me copy this question for you on the whiteboard, sharing the white screen, just using the new slide. And here we go students. So this is our question. Okay students, this is basically our question here. So let's start solving our question. The question says is, a rock is thrown straight upward from the edge of a 30-meter cliff. Okay, a rock is thrown straight upward from the edge of a 30-meter cliff. Okay, suppose student, this is a cliff. Okay, vertical cliff. Okay students, this is a vertical cliff. Here you can see that this is a vertical cliff. Okay, this is base earth, you can say, and a stone. Suppose this is a stone students. Okay, suppose this is a stone is thrown vertically upward from the edge of a 30-meter cliff. Okay, so cliff height is actually 30-meter. Okay, rising 10-meter, then falling all the way. Okay, the stone is thrown from here. Basically this is the reference point of throwing of the stone vertically upward direction, in the vertically upward direction, and it rises to this level. We can call this level as, we can say that this level is from this to this. A difference in this vertical height is 10 meter, as given in the question here. Okay students, because it is given in the question here, so I'm using is 10 meter. Okay, then it is said that the stone falls again back to the base of the cliff, and this is basically the base of the cliff, and this height is, student, this height is 30 meter. Okay, so the total distance will be Students, so the total distance will be is equals to 30, which is the falling distance, plus rising and falling from above this reference point. Okay, rising and falling from above this reference point, which is 10 meter upwards and 10 meters downward, which is total 20 meter. This is distance, students. Okay, so 30 plus 20 is basically 30 plus 20 is basically 50 meter. So this is the distance. But then the question it is asked, what is asked in the question? In the question it is the question, students, it is asked this. The question displacement is asked. Okay, so we'll solve for displacement here. So for displacement, I'm taking a new sheet here. Okay, students. So we know that the falling distance was 30 meter from this reference frame from the upside of the cliff to the base, and from above the cliff it was 10 meter upside and downside also 10 meters, students. Okay, so we know that the motion was started from here. That is, the stone was projected from above the cliff 10 meter above. Okay, and it falls down 10 meter down. So the displacement here is 0, but distance is 20 meter. Okay, from now here to here it falls 30 meter down. Okay, students, so if we are taking this as 0 and this is positive y-axis, okay, students, and this as negative y-axis, so the displacement will be basically 10 upside plus 10 downside plus 30 downside, which we can say that it is 10 positive minus 10, okay, and minus 30. So this will equals to minus 30 meter, which is a displacement. Okay, student, and here the negative sign, the answer is students, the answer is minus 30 meter. Okay, students, answer is minus 30, students, minus 30 meter. And you would be thinking that why is this negative sign is used? Negative sign is basically used, students, because it shows that motion is below the reference point from where the stone is being projected. Stone was projected from here and it fall down here. So this is positive and this is negative. Okay, students. So our answer is displacement basically is minus 30 meter. Okay, students. So this is a required answer. This is our required answer, students. Okay. So let us go further. New slide. Okay.